Welcome everyone. My name is Yamil Guevara. This is the fourth video on a video series on machine learning algorithm. Before I continue, I would like to first say thank you for watching this video. And if you like this video, please click like and please subscribe to my channel and make any comments in the comment section below. Now, in this video, we are going to be covering support vector machines. More specifically, in this example, we are going to be using support vector machines to build and train a model using human cell records and classify cells to whether the samples are benign or malignant. Now, how does a support vector machine works? Well, the support vector machine works by mapping data to a higher dimensional feature space so that the data points can be categorized even when the data are not otherwise linearly separable. A separator between the categories is found, then that data is transformed in such a way that the separator could be drawn as a hyperplane. Now, following this, the characteristic of a new data can be used to predict the group to which a new record should belong to. So that's exactly what we are going to be doing in this video. So what's the first step in creating a machine learning algorithm? I think you already know the answer to that. The first step is to always import your libraries. So we are going to be importing pandas as PD. I think you already know the usual suspect by now. PyLab as PL. Import NumPy as NP. Or optimize. Model selection. Okay, so let's run this code. Okay, so there was an error here. Let me look at it. Line, key error line. Let me see. So I think they made line. Oh yeah, in line. Let's run the code again. Let's see. Sure, everything. Okay. Okay, so good. So everything has been imported. All the libraries has been imported. So what's next? What's the second step in creating a machine learning algorithm? The second step is to always import the data set. So we are going to be importing the data set into the variable called cell df. df stands for data frame. And we are going to be using pandas to read the data from a CSV file. And our data is called cell samples CSV. And as usual, I always love to look at my data set. And the way we do that is by typing this code, which will allow me to view the first 4 rows of the data set. So let's run this code. So here it is. So here's our data. And I want to focus on the last row or last column. The last column is the class column. And this class field contains the diagnosis as confirmed by separate medical procedure as to whether the samples are benign, which equals to 2, or malignant, which equals to 4. So if the samples are benign, it will have a value of 2. If the samples are malignant, it will have a value of 4 here. So that's our class. And that's where we are going to be trying to predict using these vector, this support vector machines. Okay. So now that we have actually imported our data set, it's time to let's look at the column data types. Okay. Let's look at column data type. Give me a second. Screw this up. Okay. Let's run this code. Okay, so we have integer. All our columns are integer except for this column, bare NUC. Bare NUC seems to have some values that are not numerical. So we need to drop these rows. So we need to drop the rows that are not numerical and still keep the bare NUC column. So let's do that. Okay, yes. We use Panda. Okay, so we are going to be dropping the data, the rows that are not numerical in values, but still keep the bare NUC column and transform it into integer. So let's do that. Let's run this code. Okay, so everything worked out perfectly. As you can see, here's the bare NUC, and it has been converted to integer. So the rows that were not numerical in values have been deleted, and the bare NUC has been kept, and it has been transformed into an integer. Okay, so far so good. Let me scroll this up. Okay, so now it's time to select our features. So let's select our features. We're gonna type, and we're gonna be saving our features into features df. And of course, you already know that df stands for data frame. And of course, our features are our independent variable. The independent variable are the predictive variable. That's what they are. Of course, we're gonna be saving these features into the variable x. And of course, we always want to see our data set. Okay, so here are our features, our independent variables. And our independent variables are our predictor variables. They're the ones that are going to be used to predict the dependent variable. And the dependent variable in this example is the column class. Okay, so let's run this code. Okay, so it's our data set. Everything looks good to me. So let's continue. Now that we have selected our features, it is time that we select our dependent variable or target vector, okay? So we want the model to predict the value of class that is benign equals to 2 or malignant equals to 4. As this field can have one of only two possible values, so we need to change its measurements to, to reflect this. So let's do that and select the class as our dependent variable along the way as well. So let's do that. Non-pi. And as always, I always like to look at my data set. So we are going to be selecting the class as our dependent variable, which is going to be explained by the independent variables. And we transform this data set into integer. So let's run this code. Excellent. So everything has gone well. Okay, so let's move this up. Oh, okay. Now it is time to train our data set. Okay. It's time to actually to split our data set. Before we train it, we need to split our data set. So let's split our data set. Okay. So let's do that. And remember, we're going to be splitting our data set into two types of set. One is going to be for training the model, and the second type is to test the model. So that's what we are doing right now. Okay, so we are going to partition the data set into two sets, just like I explained. 20% of the set of the data set is going to be used for testing the model, and 80% is going to be used to train the model. Now, the random state is going to be set to 4. This means that if you want to get the same results that I'm going to be getting, you must set your random state to 4. If you set your random state to any other number than 4, then your results are going to be different than my results. Okay? So let's run this code. Okay, so far so good. Now the time has come, the time that we all been waiting for, the time to create our model. So let's do that right now. So remember, the support vector machines algorithm offers a choice of kernel functions for performing its processing. Basically, mapping that data into a higher dimensional space called kerneling. The mathematical function used for the transformation is known as the kernel function and can be of different types. So there are four types of kernel functions. There's the linear, polynomial, radial basis function, or sigmoid. Now, keep this in mind, okay? That each of these functions has its own characteristics, its pros and cons, and its equation. There's a if you think about it, we're just going to be selecting there. So since they have their own pros and cons, we are going to be selecting the default function. The default function is the radial basis function of the RBF for this example. Okay, so let's do that. So for vector machine, we're going to fit our model. Okay, so we are importing the support vector machine. Okay, and we are going to be using the radial basis function RBF, okay, as our kernel function. Okay, so let's run this code. All right, so far so good. Everything is going as predicted. Okay, so now that we have created a model, and here's where we create a model, we fit our model. Now that we have created a model, let's do some prediction. Okay, so let's do some prediction using this model. Up. So let's do some predicting. Here it is. Here are prediction. Remember that if the sample, remember the sample, if the sample equals to 2, then the sample is benign. If the sample equals to 4, then you know that the sample is malignant. So here we have a sample that is benign, malignant, benign, malignant, benign. So our model is predicting whether the sample is benign or malignant based on the independent variables that we selected as features. Now it's time to evaluate our model, okay? We need to evaluate our model, see how accurate is our model. So let's do that. Now, in order to evaluate our model, we are going to be using the F1 score and the Jaccard score. So for the F1 score, we are looking for we are looking for a score for a F1 score of 1. because a score of 0 is worse and a score of 1 is best. So that's what we're going to be looking for. So let's get our F1 score using sklearn. Metrics. Okay, so let's run this code. Here's our F1 score. We have an F1 score of 96. Remember that we were looking for an F1 score of 1 or as close as possible to 1 because an F1 score of 0 is bad. We don't want that. Okay, so now let's look at the job car score. For the job car score, we are looking for a score of 1 since it is best and not a score of 0 because it's worse. Okay, so let's calculate our job car score using sklearn. Okay, let's run this code. Here's a job car score. It equals to 0.94. Remember that we were looking for a job car score of 1 or as close as possible to 1 because a job car score of 0 is bad. So based on the F1 score and the job car score, this model is highly accurate. So the prediction, we can rely on these predictions. So that's the end of this video lesson. And I want to say thank you once again for watching this video. I want you to please subscribe to this channel and please click like and make comments in the section below. So this is the fourth video in a video series about machine learning algorithm. By the end of this video series, you should be a machine learning engineer. So I wish everybody the very best. Have a great day. Enjoy.